Okay, so welcome to the statistics, the 5820, the introduction to data science. So today I would like to explain the syllabus first. Then after that, we set up breakout rooms for you to socialize with other students. And after that, we discuss the chapter 1 of the textbook. The chapter 1 is just introduction, so just the concepts and the I explain that what will be covered in the lecture. Okay, so maybe first I want to use the just I share screen to see the syllabus. Do you see the elephant? Yes.
Yeah.
Okay. 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 Now I open the sorry. I open the syllabus. Yep. Oh. Sorry. Yep. So this is the syllabus. Probably that you can see the PDF file. So we meet the Monday, Wednesday at 7 to 8:15. So I'm thinking to upload the recorded video to the YouTube, but I don't know how well it works. Yeah, my name is Kazuhiko Shinki. So yeah, I teach most statistics classes. Have you ever taken my classes? Maybe I make a survey. Many of you, I recognize many of your name, but maybe this way, I think. The question, maybe. Okay, then save. Oh, sorry, I'm not really sure. Save. Poll open. Sorry, not sure. Polling. Launch poll. Okay, yeah. Have you ever taken my class? 1, 1, 2, 3, 4, 5, 6, 5. I see. 5, 3. Okay. So maybe the end the poll. Probably you can see the result. Yeah. So 5 of you have taken my class, and 3 of you have not. Okay. Then maybe the next question. So have you ever used R? Maybe I should launch the poll. Sorry. Yeah, I think this isn't really. Have you used R? Yes, no. Save. Not sure. Sorry, I think I'm not really good at. Maybe you can answer me by your mic. So, anyone have used R? I think at least I see the Jacob, Colin, Walid. So you have taken my course, but if you haven't taken my course, have you ever used R or any similar languages such as Python?
Yes, I've used both R and Python. This is Catherine.
So, okay, thank you.
Me too.
Thank you, Catherine.
Rizwana.
And Rizwana, have you ever used any software?
Python and R.
Python?
Yes.
And
Python
R?
and R, yes.
Vahid, have you taken my course before?
No, I haven't taken your course, but I have worked with R.
Okay, you have worked for it. Okay, so probably the R that you're comfortable with. Okay. So yeah, so this course has the prerequisite of the STAT 5030 or the STAT 5800. So yeah, it seems that there all of you have some experience in R, or anyone hasn't used any statistical software, or you used different software?
Yeah, Stata.
Stata, okay. And have you used R or Python? Not yet.
Yes.
You have.
Yeah.
Yes. Okay, I see. Okay, so previous experience in computer software such as R, Python is recommended but not required. But it seems that all of you have used the R, at least some. So probably we can skip the very the introduction of R, and we can discuss we can focus more on the materials for data science. And the another note is this course basically replaces the Mass 5890 Introduction to Data Science. So if you have taken the Mass 5890, the Introduction to Data Science in the previous years, then please don't register for this course. I think no one has registered for it. And if you have taken another section of 5890, that's totally fine. This is a topics course, so you can register for this course. But the contents are mostly similar, while I will add some more materials. And also, has anyone have registered for the DSA 6000? No? Okay, then that's fine. Yeah, so that course is also similar to this course. So probably that you cannot double count the course. It depends on your advisor, but probably not. And lecture that you have already logged in, so you don't have any trouble to log in. And the office hours, you have the link to the office hour in Canvas, so you can access office hours. Office hours are optional, so if you have questions, then you can visit office hours. If you don't have, then you don't really have to. So just the usual office hours. And the textbook, Introduction to Statistical Learning with Applications in R. So this is the bestseller, and it was taught in many courses. Even online courses are available. Have you looked at the textbook? Anyone? No?
I peeked through it, mainly looking at table of contents and stuff. I was curious, last semester, well, like this semester, are we gonna?
Sorry, I cannot hear you.
Sorry, I think I cut out there. Are we gonna follow the textbook closely this semester?
Oh, yes.
Okay, cool.
So,
I was just curious. Thank you.
So, yeah, the STAT 5030, the textbook isn't really comprehensive, so I use mostly slides. And this semester also I use slides, but I follow the textbook more in this course. Yes.
That's exactly what I was wondering. All right, thanks.
Yeah. And you can download the textbook, so it's convenient. And it's not really deep in theory, but the focus more on applications. And another textbook by the same authors, the Elements of Statistical Learning, that have more mathematical background, but still some explanations are missing. So probably it's not easy to follow that textbook, but at least the Elements of Statistical Learning, that textbook has more background information. So if you are interested in, then you can look at it, but probably that you don't really have to. Elements of Statistical Learning. That book is also available on the website. I think you can just Google. Yeah, and the computer environment. So the since this class uses R and also RStudio, so yeah, you need a computer to install those softwares. And the homework also that I require the homework submitted in a PDF format. So certainly you need a computer. And the R and RStudio, and RStudio is basically the integrated development environment. So it's a kind of the text editor or something. So it's not essential for computation, but to compile file that you need it. Yeah. And sometimes some of the students have difficulty to install RStudio. Yeah, I admit that it's sometimes complicated. And I'm using the Mac, and at first you install R, then after that I install actually my computer is installed the Mac Tech. The Tech is the software for what? To compile the mathematical formula or something. So after you install the Mac Tech, actually RStudio, installing RStudio is not difficult. But if you don't install the Mac Tech, then RStudio, maybe you have to install some additional components. So yeah, so it depends. And if you cannot install RStudio, it's not critical for this textbook, but to create documents, just that you can mimic the RStudio format, the R Markdown format, then that is fine. So at first, try to install both R and RStudio. If you have really difficulty to install RStudio, then you can skip it. And the course outline, this is a 3-credit-hour introductory course of applied statistical learning, the designed for upper level undergraduate students and graduate students. Yeah, so the motivation of teaching this course is that these days you need more statistical modeling beyond logistic regression or linear regression. So we study those materials. So 20 years ago, it's totally fine as long as you can do linear regression, logistic regression. But these days, we need more, even in industry setting. And the topics includes the bias variance trade-off, the regression and classification, and the cross-validation and bootstrap. This is largely a kind of computational methods for modeling, and model selection, regularization, spline, generalized additive models, the tree-based methods, support vector machines, and the principal component analysis and the clustering. So basically in 50-30, we covered the regression and the classification. Just regression and maybe logistic regression. So we do more materials. Maybe we have covered model selection somewhat, but except for that, we have other materials. So we have more statistical modeling, maybe a little less mathematical, the foundations, but we have more modeling.
Professor
Yeah,
Shrinkage,
and yeah, sure.
How does this class compare to 6840?
6840. 6840 is more statistical. So this course focuses on more the data analysis. So more modeling and prediction forecasting. Yes.
All right, thank you.
And neural network, I think we don't have time to cover, and the textbook does not cover either. And actually the stat 7810. The stat 7810 covers neural network these days, at least when I teach the course. But this textbook does not cover the neural network. Yeah, so the course consists of 3 components: statistical theory, computing, and data analysis. So the theory part that we do more modeling part and not much the statistical theory actually, but at least we have 3 components. Yeah, and you will do the data analysis projects in the end of the semester. So learning outcomes, these are largely required by the universities. Yeah. So yeah, the point is that I would like you to have the enough skill to choose and implement appropriate statistical models for real-world data analysis problems. So I would like you to be at a professional level to analyze data. And course structure, I mean the assignments, the quizzes and homework. I will assign the quizzes every lecture, after every lecture. So you have to choose. You have to take the quiz within 2 or 3 days. I will set the deadline. And it requires understanding of concepts, but also that you sometimes need computer implementation. So I sometimes ask you to run some R code, then ask you to report the outcome. So it's not as simple as just the multiple choice questions. So you really have to do some work. And this is the main component of the daily assignment. And homework will be assigned maybe twice or 3 times a semester. And you have 1 week to do that. So the concept, I mean, the notion is that quizzes, basically you only have to answer the final answer, right? You have to input the final answer, but the homework, you have to create all figures and explain, so, and in 1 PDF file. Yeah, and the full credits are given only when your work has a professional level quality. So if you have some code, but it's not readable and no outputs, no figures, then you may not get full credits. So if you are hired as a statistician, even as a part-time job, at least the results should be readable for general audience. So that is the concept. And midterm, 1 take-home exam. So it's similar to homework. So work independently. And basically, I assign some data analysis problems, and then you have to submit kind of a report or essay to answer those questions. And the final project, this is also similar to STAT 5030 or the 6840. So this replaces the final exam. So implement data analysis using R on real data of your choice and make a 12 minutes presentation in Zoom. So this is the synchronous course. So presentation is in real time on either April 21st and 26th or 28th. And submit your presentation slides. Yes. Yeah, and the schedule will be determined after the midterm because some students may drop the class. So that's why always I set presentation schedule after the midterm. And no show in presentation will not get course credits. Usually this is rare, but in online environment since last year, last spring semester, actually some students didn't submit the final projects and they don't get the credits. So just be careful to make presentation on time. You don't have to be perfect, but you have to be present at the time for the scheduled presentation time. And submit a project plan by April 1st. Project plan is just 1-page summary of your data and analysis plan. And I will provide the details later. And you can also attach the data sample. And the plan will be returned with comments while no credits are given to the plan. And sometimes I ask students to resubmit the plan. So usually if the plan is infeasible or you cannot really analyze the data, then I ask you to submit the plan. But the only fundamental errors that I will ask you to resubmit the plan. And the grading, the quiz and homework 40%, midterm 24%, and the final project 36%. So last semester and the last winter semester, I found that students need spend more time to do quizzes and homework. So I put the higher proportion here, 40%. Yeah, and this is the grading scale. So I hope that many people get a good grade, A to B minus, and yeah. And the tendency of this class is that actually many students get an A. I think last semester 50-30. I think maybe a half of the students get an A, even more than half. But still, some students failed. So really, we have the wide distribution for the grade. So yeah, and yes, and for final project, the grading is a little different. So the maximum is 100, but only up to 35% of students can get more than 80 points. And the majority of students get 80 points. That is basically the excellent presentations or good enough presentations. And if presentations have some weakness, then you will get the lower than 80. Even some students get 40 or 50. So as long as you make a reasonable presentation, that you have a good chance to get at least 70 or 80. So this is because I would like to appreciate excellent presentations. So if I give everyone 100, then basically the grade is determined by just quizzes and midterm. So I would like to appreciate the excellent presentations. So that's why I put this. And 18 points are basically enough. So if average is 80 points, then you can get an A. So I think you don't have much trouble with this grading scheme. So I have this grading scheme for more than 10 years. Maybe just 10 years. Yeah, so these are some important dates. Take home midterm, probably, it's due on February 25th. And spring break, basically, even I don't mention it, everyone can recognize it. Yeah, people say that if you don't know the spring break, ask students. So you should know that. And final project plan due April 1st, and final presentations the April 21st or 26th or 28th. So only 9 students. So possibly that we can finish by 26, maybe, I don't know. But okay, so we will decide it later. Yes, some references that if you are not familiar with R or you want to remember how to use R. And I think the first one, the R book, and the second one, the practical regression and ANOVA using R. And the last one, the introductory statistics with R, are available online. 3 and 4, I'm not exactly sure. Maybe you have to buy a book. And the contents are pretty similar each other. Yeah. Okay, so this is the syllabus. So do you have any questions about the course? Anyone? The grading or? You don't have anyone? Andrew, do you have questions? No?
No, I don't have.
No. Okay. Thank you. And especially if you are the first time to take my course, do you have any questions? Rizwana or Bahit? Or?
Yeah, I was trying to download MarkDex, but is it can I download it in my Windows?
Windows, I think the LaTeX is a little different system. So the LaTeX is a little bit complicated system, and you have to download the piece by piece. But the Mac, basically put everything in one package. That is the Mac tech. So Windows, I don't really recommend to install LaTeX beforehand. Just try to install the RStudio first. Then probably that's
I
easy.
already have RStudio.
Oh, okay,
Yeah.
then that's fine. You know, if you have installed RStudio, you don't have any problem. So you don't have to
Oh, okay.
install the Mac Tech or LaTeX in Windows. You don't have to.
Okay, thank you.
Anyone, Kathleen, or do you have questions? No?
Nope, I'm okay. Thanks.
Okay, great. Okay, so if you have questions later, you can ask during office hours, after class, and so on.
Okay.
Okay, so now how many students we have? I think the 10 students. So maybe I will make maybe 2 breakout sessions to interact with each other. So you can discuss the what courses are you taking? Maybe your major, maybe of course your name, and name is displayed, but okay, what courses are you taking, and what statistics courses have you taken? And any other topics like what you do in the winter break, or generally what you are interested in. Okay, so I will I will open the breakout session. Sorry, I don't know how to break out rooms, 2 rooms. Yeah, so you can, I will break out the rooms, 5 students each, so that you can discuss each other, maybe for 5 minutes or maybe a little more, 5 minutes. Yeah. Okay, go ahead. Okay, so the breakout rooms will be closed in 12 seconds. Can you hear me?
Yes.
Okay, great. Okay, so now we start chapter 1. I think I have some trouble to listen to my voice. But anyway, okay. Okay, so chapter 1, introduction. So in undergraduate level, we study probability and statistics. And what's the difference between probability and statistics? Sorry, I have so much trouble with my sound. Test. Still, can you hear my voice?
Yes.
I think I have some trouble.
Are you on the you're writing the notes on the iPad, correct?
I think I logged in 2 computers, so that's why.
So if you mute your computer and then keep like the iPad on, for example, then it should not cause
yeah,
any.
maybe I have to mute my iPad. Then still I can write on the iPad. Probably that's a better way to go. Yeah.
Yeah, you should be
So
able
you can
to.
hear, right?
Yes.
Okay, great. Then share screen. Okay, so can you see slides?
Yep.
Okay, great. So what's the difference between probability and the statistics? So this is a word from the professor, the Krostelev at Wayne State a few years ago. And the difference in probability and the statistics is here. So probability is to design a casino. So you know everything, that you know the probability to get a jackpot, you know the probability you get, for example, the 1 in a roulette. So you have all mathematical assumptions, and based on those mathematical assumptions, that you construct probability theory. And statistics is to play in a casino, so based on data. So if you play slot machine 1 million times, and if you get the jackpot 10 times, then probably the success probability is the 1 in 100,000. So that is the statistics. So you don't really know the probabilistic assumptions, but based on data, you see what's happening. But still, the statistics is developed based on probability theory. So these two are closely related. So here is the typical example. So you roll a die 100 times, out of which the face of 1 shows the 10 times. So interpret the result. So probabilist thinking is here. The chance of getting the face of 1 is 1/6. And let x be the number of ones when you roll the die the 100 times. So actually, on average, you get maybe 16 or 17 times. And the probability that you have exactly the 10 ones, the face of 1, 10 times, is equal to 0.021. if you think about probability of the x is less than or equal to 10, that probability is 0.043. So we got a kind of rare event. So that this is the way that the probabilists that think about the rolling dice. So statisticians' answer is different. So we have the 10 over 100. That is the answer we have. I mean, the data we have. So the best estimate for the probability of getting the face of 1 is 10 over 100. This is actually maybe smaller than 1/6, 0.1. But of course, we have some variability. So we have some randomness when you try this, if you do this trial 100 times. So you have statisticians sometimes make some confidence interval for the probability that is the 0.049 to 0.176. So maybe even if you assume the probability of getting the face of 1 is 1/6, that isn't very unrealistic. So it's certainly plausible. So this is the difference between probabilists and the statisticians. So always the statisticians estimate some numbers based on the data. So this is the one interesting example also. So what is the probability to get the head side up when you flip a penny? Maybe actually this should be the spin. You spin a penny. The spin, you rotate coin so many times. So actually the heavier side that comes to the bottom with higher probability. If you flip the coin, maybe it just flips a few times, so it's the situation is a little different. And if you spin a penny, then actually only 20% or 21% of probability it lands the head side up. So it's totally different from 50%. In mathematical questions, sometimes you assume that the coin is fair and to get the head side up is 50%. But actually, if you do experiments, that is 20% or 21%. So sometimes making some probabilistic assumption that does not match the data. So this is the difference between the probabilistic way of thinking and the statistical way of thinking. Of course, the probability theory can be constructed based on this 20% probability. Then you can get more accurate inference. But this is basically the fundamental difference between probabilists and statisticians. So probabilists start with some mathematical assumptions. Statistics, the base is based on the data. And the data science is to extract knowledge or insight from data. This is the Wikipedia's definition. And the data science is perceived as a combination of these components. So one is the statistical or mathematical modeling. And the another part is computer implementation. And the third part is data analysis and the implication to the real world problems. So it's the same as statistics, basically, but basically data science, the implication to real world problems is emphasized. More business applications are emphasized. But basically, the data science has very similar meaning to statistics. We will see some slight difference in terms of philosophy, but that's data science. And what's machine learning? Machine learning is very hot area. So the data scientist is a hot job, but the machine learning engineer even earns more. So what is the machine learning? So machine learning is a branch of mathematical statistical modeling of the data, but it emphasizes the automatic detection of the pattern. For example, the character recognition problem. So based on the sample of the 10,000 handwritten letters, we want to automatically classify the additional 1 million letters or something. So automatic decision making. So that is one important thing. And also the focus is on forecasting performance. So the interpretation is not that important. So in statistics, interpretation is important. For example, we developed a vaccine for the coronavirus. Then at first, we want to see if that is effective or not. Or if you think about the maybe the parents' educational level and the children's the academic achievement, then we want to explain the, okay, so this is the parents' educational level, and this is the children's academic achievement. Then if we have data, maybe our first interest is slope is significantly different from 0. So statistics that tests the slope. But here, the machine learning, we are not interested in that, and we want to develop more, accurate prediction model. Maybe the truth may be like this. Okay, so we want to estimate this complicated curve, even though we don't really know if the slope is significant or not. Also, it doesn't really care the correctness of the model. So if we think about the explaining someone's weight by someone's height, and if we got y is equal to maybe 1.5 plus the 2.3 times x to the power 2.2, and x is the height and the y is weight, probably no one believes that this 2.2 in the exponent, the x to the power 2.2, makes physical sense. If x squared or x cubed, it makes some sense, but the 2.2 does not make sense. But usually the machine learning doesn't care about it. So the forecasting performance is more important than interpretation. Yeah. And statistical learning is mostly the same as machine learning and is not a popular word besides our textbook's title. The most machine learning models have a statistical foundation, and the word, the statistical learning, can be interpreted as the machine learning with emphasis on statistical justification. Oh, sorry. And prerequisites. So you need many components to study data science. So data science requires a variety of knowledge and ideas, the mathematics and the probability, statistics, and machine learning, the computer implementation, and data analysis. So basically, the mathematical portion here, and the computational portion here, and the data analysis component here. And if you have just know the mathematics, maybe just the your knowledge is limited to this area, or maybe at most to this area. Then we construct statistics beyond that. Then after and more complicated modeling in machine learning. Then after that, we do computer implementation and the data analysis. So in terms of the flavor, the 50-30 is really similar to our course. So maybe this should be 58-20. But yeah, so it needs the more than mathematics. So mathematical foundation, computer implementation, and data analysis. So if you have taken 5800 but haven't taken 50-30, at least you have to be careful that we need the computer implementation and the data analysis part. So data analysis part is mostly for maybe lab session and also the final projects. Yeah, and here some notes on how are data perceived by statisticians. So are there any computer science major students here? No?
I am.
Okay, great. And any others? No? And okay, so computer scientists, so they are good at numbers, right? So they are good at computing, right? And they can handle a large data. So it sounds that they are stronger than mathematicians or statisticians in terms of dealing with data in all aspects. But sometimes it's important to perceive the data as realization of random variables, and some computer scientists sometimes miss that concept and just the data as just numbers. So here is the typical example on how the problem is perceived by statisticians. So example, how is one's academic ability determined? Maybe some just a general ability to take tests, or maybe general ability to do mathematics or whatever. And the people that analyze the academic ability, they try to compose the academic ability into the genes, genetic factor, and environment factor. For example, if you have many twins, then genetic factors are the same. But if environments are different, their scores are different. So in that way, that you can see how much of the ability is explained by the environment. And often, for example, the physicists, they just decompose ability into gene and environment. But usually, we have some errors. So even though the genes are entirely the same, maybe twins or the triplets even, and the environment looks the same, raised up in the same family, and still their performances are different. And why? Maybe physicists claim that, okay, so we have slightly different genes or slightly different environments. Okay, so they are given slightly different Christmas presents. But the statistician's way of thinking is, okay, so genes explain some part, environment explains some part, but the random error, so random variable explains the remaining part. So some part of the ability cannot be explained by either genes or environment. Maybe this is not scientific way of thinking, but this is how statisticians deal with the data. And the statisticians deal with the phenomenon in the real world. So error may be ultimately explained by genes and environments, but it is reasonable to assume that there is an uncertain component, since we don't have all the information on genes and environment. Yeah, I think there one quiz related to this today. Yeah, and questions so far? Yeah, so this is sometimes some political correctness problem, but some people claim that the genes doesn't matter and environment explained everything in terms of some ability, and some people they believe that the some ability is closely related to genes. Okay, so now that we go on to the statistical modeling, and that we have the two types of learning. The one is the supervised learning, and the other is unsupervised learning. So in terms of the X and Y, so supervised learning, unsupervised learning. So supervised learning try to explain Y by X. And unsupervised learning, we try to explain Y by X in some way, but actually we don't have this information. So we only have the information of X. And the supervised learning is modeling problem when response variable Y, called label, is available for the data set. For example, that we have the set of animals and that we have the weight, height, and so on, but we also have the label. The animal is either tiger or lion, for example. And we want to explain the species by weight and height and so on. So we have both X and Y in the data. So the answer is known for the sample data, but for new data set, we don't have Y, so we want to explain Y by X. So some examples, estimating a formula for height of students given the weight of the students. Height and weight data are available for 100 students. So then, given the new student's weight, that we can predict the height of that student. So this is regression problem. So we have height and weight. So the weight is here and the height is here, and we have some data. So we do, for example, the linear regression here. Then this is the predicted height given the weight. So this is the regression problem. And another famous problem is the classification. So establish a criterion to distinguish the 3 species of flowers when the characteristics such as color, height, and diameter of flowers are available. And the species of 90 flowers are also available. So we have the 3 species and we have data set. So okay, so one species is represented by triangle, another species, this square, and the other, the circle. Then we have maybe triangles here. Maybe this is the color, maybe brightness. And this is the height of the flower. Then possibly we have this data. Then we can see that probably the best way to distinguish these 3 species is maybe like this. So species A, B, C. So this is the classification problem in supervised learning. Do you have questions? So in 50-30, we have covered the first one, regression. The classification, 2 groups, we do logistic regression. More than 2 groups, we haven't done. And unsupervised learning, actually, maybe the 90% of the book talks about supervised learning, but the other 10% unsupervised learning. So unsupervised learning is a modeling problem when a label is not available for the data set. So the answer is unknown for the sample data. So it's a little bit vague. So I would like to have 2 examples. So one is for example, the developing a business cycle indicator when 30 economic time series data, such as monthly unemployment rate and monthly industrial productions, are available. So this is the so-called the dimension reduction problem. Okay, so yeah. So for example, you have unemployment rate data. So yeah. So unemployment rate. So this is time. So unemployment rate is higher in recession and the lower in expansion. So if you have 2 recessions and 1 expansion in this graph, then okay, so t is equal to 1 to 100, then it looks like this. And maybe another variable is maybe inflation rate and time. Time is the same, maybe 1 to 100. Inflation rate is higher when economy is expanding, so and lower in recession. So inflation rate probably should be like this. And how about industrial production? Maybe we have to have the same scale. So maybe industrial production grows. Then industrial production grows more in economic expansion. So probably the graph is also like this. Maybe I want to make it a little closer to this. Okay. Okay. So then we can summarize the data of these 3 variables. Okay. So unemployment rate that in the other way around, but if we think about, for example, unemployment rate, maybe negative of unemployment rate, plus maybe inflation rate, and the industrial production is important. So maybe the 2 times industrial production grows, then we can get this X, maybe I will say Y is not good, so maybe Z. So if we define the Z as this variable, then this is more reliable business indicator. So Z maybe even smoother curve than this, 1 to 100, then maybe like this. Okay. So each statistics have some unreliability. Maybe unemployment rate is maybe distorted by some government policy. Inflation rate is affected by, for example, increase in tax on tobacco or something. And industrial production also is affected by temperature or something. But if you aggregate those variables, then this Z is more reliable estimate of the business indicator. So it makes sense, right? And we don't really have answer. So just we want to summarize all economic data into one more reliable business cycle indicator. So this is so-called the dimension reduction technique. So we have the 3 variables, but we just summarize these variables into one variable. And 3 to 1 is simple, but maybe 100 to 1 or 1000 to 2. So that is the dimension reduction technique. Yeah, and the next example is the actually classification problem, but the unsupervised case. So think about in the last slide that I do the classification problem, but we know that which observation corresponds to which species. But here, we don't have labels. So think about maybe 3 species of flowers, but we don't know the each flower that belongs to which species. But suppose data is like this, then you can clearly see 3 clusters. Maybe we don't really show classification, but we say clustering maybe. Clustering problem. So even if we don't know label, that we can see that these 3 groups are different, right? So in this case, it makes sense to classify the observations into the 3 species. So this is so-called, yeah, I think the more often we say clustering, but also we can say classification without the supervisor. So these are unsupervised learning. So these are dealt with the chapter 10 of the textbook. So just only maybe 1/10 or 1/9 of the entire textbook. Do you have any questions so far? So obviously, unsupervised learning is more difficult because we don't have a supervisor, or we don't have label, I would say. And also, some data set is the semi-supervised learning. So this is, partially supervised. So suppose we have 100 observations. X1 to X50 have corresponding Y. But maybe X51, maybe usually more observations are unsupervised. So maybe X51 to X1000, we don't have Y values. So for this kind of data set, okay, partially we have the label, but the other part, we don't have label. So this is called the semi-supervised learning. So have you heard of the Kaggle data competition website? Kaggle, K-A-G-G-L. Yeah, okay, Kaggle. Kaggle is the data competition, and usually the format is like this. So we have the training set, the yellow part, and we are given the additional data set, but only the predictors. Then so the competition is to predict the Y51 to Y1000. So in some sense, the Kaggle data competition is always the semi-supervised learning. The people usually don't use this information, I mean the additional information, this orange part, but that is actually a kind of semi-supervised learning. And semi-supervised learning appears in the translation, for example, the English to Chinese. So many documents are available in English, and also in, many other documents are available in Chinese. But some documents are available in both languages. The famous, for example, novels, probably Shakespeare novels were already translated into Chinese. So a very small number of documents are available in both languages. So maybe I would say 1,000 documents. Yeah. But only English is available for 10,000 documents, and possibly maybe there are another 5,000 documents are available, but only in Chinese only. So in this case, we can use this 1,000 documents information, of course, but this additional information is also useful to identify the structure of English language. So this is semi-supervised learning, and we don't cover in the course, but I would like to conceptually explain it. What time now? Okay, so still 10 minutes. Okay, and some overview of the textbook. One overview of the textbook, and the chapter 2 is the chapter to explain the concepts. So we have the regression example, but we have the basic concepts such as the bias variance trade-off, more conceptual. And chapter 3 to 4, so these are basically statistics, regression and classification, so statistics. And chapter 5, the resampling methods. This is actually the computational technique, you can say. And chapter 6 to 9, that we have more machine learning technique, and this is the supervised learning. And chapter 10 is unsupervised learning. Yeah, so these are the concepts. And the regression and the classification that you probably see what's happening. And the resampling methods, I would explain it. And maybe I would just give you some brief ideas of some other sections. Yep. So copy. Paste, push. Okay. Sorry. Okay, maybe. Okay. Yeah. So okay, so at first, chapter 6, the regularization. So regularization. Okay, so linear model selection. So model selection that we have studied in the 50-30 also. So suppose we have 100 possible predictors, but we have to choose maybe just the best ones. Then how to choose the 3 predictors out of 100? That is the subset selection. But also that we have the shrinkage method. So it's called the lasso or rich regression. So I would like to explain that idea. So think about the linear regression. So linear regression is not super complicated. So we have X and Y, and we have some data points. Suppose we just the one-dimensional X, then we have, just a straight line here, right? So this isn't very complicated, but suppose we only have 1 point, okay? So this is extreme, but in reality, maybe we have the 100 predictors and we have maybe 80 data points. Then we cannot really determine the line. Okay, so we have this line, anyway, it's perfect, right? So we cannot really choose the line. But suppose okay, so suppose this point is maybe the 2, 3, and how to determine the line? Okay, so as long as we have the y minus 3 is equal to maybe a times x minus 2, any line that goes through 2, 3, so it should be fine. So this is y is equal to ax minus 2a plus 3, right? But suppose that we have one more restriction, then still that we can determine the line. Okay, so we want to minimize, the okay, so if we have the y is equal to ax plus b, we want to minimize the a square b square, a square plus b square, as well as the error. Then, so the idea is that if we have the large coefficients, the model is unstable, the very small change in x, the change change the predicted value. So if we want to minimize a square plus b square, then actually we have, okay, so this condition, but also the minimize the a square plus the negative 2a plus 3 square, right? So this is equal to 5a square minus maybe 12a, right? 12a plus 9, okay? Then a should be equal to 5, 12, so I think the 6 over 5, right? 1.2. So the line is, regression line is y is equal to maybe the 6 over 5x minus, maybe we use the we use the 1.2, so 1.2x minus the 2.4 plus 3, so minus 2 times 1.2 plus 3. So this is 1.2x plus 0.6, right? So you can determine the line. So this is the shrinkage, so-called the shrinkage method. And I've explained why the shrinkage, but basically we would like to choose the smaller a square plus b square. So the absolute value of a and b gets basically smaller in some sense. So in this way, if we impose this additional assumption, then still we can estimate the line. So that is sometimes useful technique. So this is so-called the shrinkage method. So instead of the subset selection that we have this kind of technique. Yeah, and yeah. So I think it's already 15. Yeah. So this is the subset selection. And we have some others, they're moving beyond linearity. Okay, so chapter 7, we would extend the regression model into the more models. So especially the spline. So the idea is that spline's idea is basically, the line graph. So the spline, the idea is, so suppose we have data and the pattern is really complicated. So we have the x-axis and y-axis. Suppose we only have one-dimensional x, but the pattern is really complicated. Okay, and if you connect everything in as a line graph, just straight line, okay, then maybe this is too smooth, but okay, so suppose that we have a slightly larger noise. Then of course you can make a graph y is equal to f of x. So this is the piecewise linear function. But this is really ad hoc, and you don't really probably you don't really think that this is true. So the one way is okay, so this is piecewise linear, but suppose the piecewise cubic function and see what happens. Then if the graph is piecewise cubic function, probably it's a little smoother graph, like and probably it becomes a little more plausible. And sometimes that we don't really require this kind of assumption, like so the graph does not have to go through all the points, but maybe piecewise cubic function, but suppose we only have the several not points such as this, then maybe the graph piecewise cubic function is like this. So we can balance between the flexibility and the fit to the data. So this is the spline. So the basic idea is the piecewise linear, but we relax, we make it smoother, such as piecewise the quadratic function, piecewise cubic function, and so on. And not piecewise at each interval, but the piecewise in the 3 intervals or something. So this is the idea of the spline. Yeah, and some other method, the tree-based method. Tree-based method is basically we separate the cases. Okay, so we have the entire space. Sorry, it's already 8:17, but the tree-based methods that we separate the lines. So yeah, just a moment. Maybe this is the last one. Yeah. So the idea of tree-based method is, okay, so suppose to think about COVID. So COVID, actually the age and the gender are 2 important factors to determine the risk. And lower age, you have lower risk. But if you are female and you are younger, then your risk is much lower, much lower. So that means that if we think about the case that okay, so this is relatively high risk. But if you think about okay, so we only have 2 scales, but the female and male. And if we separate in this way, okay, so age is lower than female, then the very low risk. And male and age is lower, low risk, but not very low risk. Okay, so like this. So we separate at first by age, but after that age, maybe the female has lower risk to get COVID symptoms. So in this way, that we can separate the plane of the predictor variables into several pieces by separating cases. So this is the idea of the tree-based method. So tree is obviously, at first we separate by age. Age is more than 50 or less than 50. Then after that, the male and the female. So it's a kind of tree. So this is tree-based method. And we study several other techniques such as support vector machines and also the unsupervised learning. Okay, so this is the overview of chapter 1. So I will upload the quizzes to today's lecture. So just do it within a couple of days. Okay, so do you have any questions?